Now, let me ask you this. With respect to x, what is the derivative of this? Ax to the k. When you derive this, you're going to get ak multiplied by x to the power k minus 1. So that's when you derive ax to the power k. You'll get akx to the power k minus 1. Now, I want to introduce you to something called an antiderivative. Now, when we derivate this, when we derivate ax to the k, we get akx to the power k minus 1. What does this mean? This means that the antiderivative of akx to the power k minus 1 dx, this will be the same as ax to the power k, because it's an antiderivative. It reverses what we have done. So this statement holds true, or this equation holds true. You can add a constant, because the derivative of a constant will result in 0. This means we can possibly have a constant on the side. So let me just do that. Let me just add a constant. Now, okay, or I'll do it later. I'll just add a constant later. For now, it will disturb the main idea that I'm trying to show you here. Now, remember when you were derivating, you could take the constant outside. The same is true for integration. You can take the constant outside. In this case, the constant is ak. So you can take ak outside, and you'll have x to the power k minus 1 dx. This will be the same as ax to the k. Then if you divide both sides by ak, then the ak will cancel ak, then you will be left with the integral of x to the power k minus 1 dx. Then the a will cancel the k, the a I mean, not the k. A will cancel a. So you'll have x to the power k divided by k. So this is the formula that I wanted to show you, but it's a little bit complicated. I'm going to simplify this to the method that you know. Now, let k minus 1 equals n. If k minus 1 equals n, that means that if I add 1 on both sides, then I'll have k equals n plus 1. Now, I'm going to substitute this in. Now, I'll have the integral of, or the antiderivative of. Now, k minus 1 in this case is n. So I'm going to have n. I'm going to have the integral of x to the n dx. Now, here I'm just going to have x. What's my k now? K is equals to n plus 1. So I substitute n plus 1 in this k. Then this is what I'm going to have. Then I can then add my constant. I'm pretty much sure you're familiar with this formula. I just showed you how it arises, because we are anti-deriving this. We are reversing that. So what does this mean? This means that if I have the integral of x to the half dx, this will be the same as x to the power half plus 1 divided by half plus 1 plus a constant. Then this will be the same as x to the power 3 over 2, since 1 over 2 plus 1 is 3 over 2, divided by 3 over 2. Then you can multiply both the numerator and the denominator by 2 over 3. Basically, it's just the reciprocal of this, 2 over 3. Don't forget to have that constant there. Then this 2 will cancel this 2, this 3 will cancel this 3. Then you'll be left with 2 over 3 x to the power 3 over 2 plus c. Now, that is the integral of x to the power half, or that's the antiderivative of x to the power half. But now let's look at this. Let's look at this formula. Notice that I have a denominator here. Now, n plus 1 cannot be 0. We are not allowed to divide by 0. That means this formula has a restriction where n is not equals to minus 1. Then we can use this formula. For any value of n where n is not minus 1, for any values except for minus 1, then we can apply the formula to integrate or to find the antiderivative. So this is just the introduction of integrals or antiderivatives. Now, what are the properties of antiderivatives or integrals? Now, the first thing I showed you is like if you're integrating a function, but then you have a constant, you can take the constant outside. This will hold true. Dx. Now, if I have the integral of f of x plus g at x, I put plus minus dx. If I'm integrating the sum or a difference of two functions, this will be the same as the integral of f plus minus. If they put minus here, you'll put minus here. If they put plus here, you'll put plus here. Don't write plus minus when you are doing your calculations. Here I'm just showing you like it's a general formula for this case. Now you can do this, then say the integral of g at x dx. For now, that's what I want to show you. Now we can do this and integrate the square root of x minus 5 divided by x squared dx. Now what you're going to do is you're going to say the square root of x divided by x to the power 2. This will be x to the power minus 3 over 2. Now minus 5 divided by x squared, this will be the same as minus 5 x to the power minus 2 dx. Now you're going to apply this. Now. Or you can integrate. It doesn't really matter if you apply or don't apply this, so long as you know what you're doing. But let me just do that. This will be the integral of x to the power minus 3 over 2 dx minus 5. I applied this one where I take the constant outside. Now I'm going to take the 5 outside. Then I'll have the integral of x to the power minus 2 dx. Now, I'm going to apply that formula now. So I'll have x to the power minus 3 over 2 plus 1 divided by minus 3 over 2 plus 1. Then I subtract 5. Then the integral of this will be x to the power minus 2 plus 1 divided by minus 2 plus 1. Then don't forget to add that constant there. Then from then it's just a matter of simplifying. Minus 3 over 2 plus 1. This is the same as 1 minus 3 over 2, which is just going to be minus half. So we'll have x to the power minus half divided by minus half. Now minus 2 plus 1 just going to be minus 1. Then you'll have 5x to the power minus 1 divided by minus 1 plus a constant. You don't necessarily need to show all steps. I'm just showing you like how you arrive to this point. I'm showing all steps, but you don't have to do that as long as you know what you're doing. Now, this will simplify to minus 2 over the square root of x Since I have negative and negative, it will be positive. So I'll have 5, and the negative just tells you that this is below the denominator, below the fraction line. It is a denominator. Then you'll have 5 over x to the power 1, which is the same as x. Then you add constant. So that's what you're gonna have. That's what you're gonna have as the integral of this. So you can basically practice this. Hopefully you'll get good at it. Now there are some functions where you cannot apply that formula I showed you. Let me just get onto that. Let me just get on to functions where that formula is not applicable. Remember what I said? I said that the integral is the antiderivative. That means that what happens when I derivate sine x plus a constant? When I derivate sine x, I get cos x. This means that when I integrate cos x, I'll get sine x. Just gonna add a constant there. What happens when I derivate cos x? I'll get negative sine x. So I have the integral of negative sine x equals cos x. Now, what happens when I derivate tan x? If I derivate tan x, I'll get secant square of x dx. So that means the integral of secant square x will be tan x, since the derivative of tan x is secant square x. The derivative of cos x is minus sine x. The integral of minus sine x will be cos x. The derivative of sine x is cos x. That means the integral of cos x is sine x. So that's just, I hope you get the idea what integration means. What happens when I derivate arctan x? I get 1 over 1 plus x squared. So this is basically it. The integral of 1 plus 1 over the integral of 1 over 1 plus x squared, this will be arctan x. Don't forget your constants. Okay. Now, what happens when I derivate the natural log of x? What happens when I derivate the natural log of x? I get 1 over x. Now, suppose that x can be negative. We have to account for that by including the absolute values instead. We have to include absolute values to account for the possible negative values of x. Now, this is basically it about integrals. As long as you know how to differentiate, then you can integrate it. Now, suppose I have 1. Let me not say 1. Suppose I have 11x squared minus 6x plus 5 divided by x dx. And I'm looking for the integral of this. So I'm just going to simplify this. 11x squared divided by x, it's going to be 11x. Minus 6x divided by x, it's just going to be minus 6. And then 5 divided by x will be the same as 5 into 1 over x dx. You don't need to represent it in this way. You can still write 5 over x, is still fine. Then you just apply the formulas I showed you. So you'll have the 11, the integral of x dx, minus 6. I can do this thing because 6 is a constant. Then you'll have something like this. Maybe I should include it. The integral of a very, very, it's just going to be one dimension thing here. It's just going to be, suppose for simplicity reasons, you can just let this be 1 or anything. Then this will be x. Because here it's just going to be any infinitesimal. So it's just the integral of any infinitesimal number that's extremely small, then you'll get x. So that's if you're integrating with respect to x. Now back to the question. I just took the constant outside. Then you'll have something like this. Then you'll have 5, the integral of 1 over x dx. Now what's the integral of x? Apply those formulas I showed you. You'll get that this will be x squared over 2. If you apply that method I showed you, then this will just be x, since this is just an infinitesimal. It's just the infinitely small x in this case. So when you integrate that, you'll get x plus 5. The integral of 1 over x, that's what I was showing you here. It's gonna be the natural log of the absolute value of x. So you'll have 5, the natural log of the absolute value of x. Then you can add a constant. Then you can simplify here. So it's just gonna be in this form: 11x squared over 2 minus 6x plus 5 ln absolute value of x plus a constant. So that's how you can integrate this and memorize the formulas for which you derive it, and the integral of that will give you that function. So this is basically it about integration. Now on the next video I'm just gonna do definite integrals, where I have the boundaries, the limits of integrations. Don't forget to share and subscribe. Thanks for watching.